Hello, welcome to this online J4K session. My name is Delabassee. I work at Oracle in the Java platform group. So today the session is titled Java and the 40 version. Why this title? Well, if you're following what is happening within the Java space, but also OpenJDK, you might think that there are a lot of Java versions. In addition, if you put next to that OpenJDK projects such as Project Loom, Project Timbre, Project Valar, it's a bit daunting to understand what is going on. So the goal of this session is to give you some kind of snapshot overview of Java in 2020. So what is new in 2020, but also trying to explain how, for example, Project Timbre fits within Java in 2020. So the first thing I want to discuss is 2020 because it marks the 25th anniversary of Java. So this is an important milestone. And if we look back, I believe that there are two key milestones within those 25 years. The first one was around 2006-2007 when Java was open source. So that was the beginning of OpenJDK, the project as we know it today. Then the second milestone is a more recent one, and that is the new release cadence that we put in place a few years ago. So let's discuss that. So this slide shows the content of Java 9. So Java 9 has been released in September 2017. Before that, Java 8 was released in March 2014. So that basically means that we had to wait over 3 years and a half to get a new Java release. 42 months to be more exact. You can see that the content of that release is pretty broad. There are a lot of new features. And that's an issue because as a developer, that basically means that you get a new release. And as soon as it's GA, you basically have a lot of features in your hands that you need to try to understand and master. Not only that, until Java 9, the main factor that was driving a release was the content. So that means that if a given feature that was slated to be included in a given release is not ready, the whole release has to wait that that feature is ready. If we look at Java 9, for example, Java 9 has been delayed 2 times because of that. And that's really an issue. So starting Java 10, we adopted a different approach, and that is a predictable release cadence. So that means that every 6 months we have a new release, regardless of the content. So some release might have more content, more new features, and other release might be more modest when it comes to new features. Again, what is driving the feature is not the content, but it's really the date. Every 6 months there is a release. And that's not really an issue because let's say that a given feature is not ready to be released in the next release. Well, that feature just has to wait another 6 months. That was not possible before. Before, if a feature was not ready to be included in the release, we had 2 options. Either we drop it and we wait another few years, or we delay the whole train, the whole release. Now with the predictable release cadence, we don't have that issue anymore. So if we look at 2020, we got 2 releases, Java 14 in March of this year and Java 15 a few weeks ago in September. So what I'm going to do today, I'm going to go over some of those features. I will also try to do a few demos to highlight, for example, some of the features coming from Project Timbre, and that should give you an overview of some of the new capabilities that we have at our disposal in 2020. Before we do so, I want to quickly discuss how we are now able to how we can foster innovation more quickly. So the first thing, the predictable release cadence. Every 6 months we have a release. That's something that is now proven to be effective. The second thing is the JDK enhancement proposal. So that's a mechanism, the JEP mechanism, that is used to basically put anything significant within the platform. So any significant features should go through that JEP mechanism to be included into the platform. Included or removed, because that JEP are also used to remove older or less popular features from the platform. Then we have multiple feedback mechanisms at our disposal. So the idea is that once a feature is more or less ready, we want to give it to developers so that they test it and provide feedback. So for example, we have preview features. Preview features are used for Java language features. So given the importance of a new Java language features, we want to make sure we got it right. Because once it's in the platform as a final features, it's there for decades. So preview features allows us to include into the platform new Java language features, which are specified and fully implemented. And the idea is that we want to allow developers to use those. And if the feedback that we get in return shows that, okay, there is a little gaps here, or maybe we should do that in a different way, well, we can do some small adjustment before we put the final stamp on that preview features. And we will see that Project Amber is leveraging that mechanism a lot. Next to that, we have experimental features, which are mostly used for hotspot features. So we'll see later on that, for example, ZGC has been included in the platform from 11 to 14 as an experimental feature, and then in 15 it has graduated as a production features. And finally, we have incubator modules, which are used, as the name implies, to incubate API within the JDK. Early access JDK builds are basically used to give developers, and I would say advanced developers, some early prototype of a given project. So for example, Loom has multiple prototypes, and they were given to developers through that early access JDK build mechanism. Finally, we have Project Scara. So the goal of Project Scara was to look at an alternative to Mercurial. So you might know that OpenJDK is using since the beginning, in fact, Mercurial as its source code management solution. Scara was looking at an alternative, and that is Git. In addition, Scara has also looked at hosted Git solution. GitHub was selected, but it's important to mention that OpenJDK, even though since September is being developed using Git on GitHub, OpenJDK is not locked to GitHub. Scara is also developing additional tools on top of Git to use the existing development workflow of OpenJDK. So Scara 2020, that's the important thing to mention is that since September, the OpenJDK development is done using Git on GitHub. So Java is free, and we put everything in place to be able to deliver feature faster. And guess what? It works. Clearly, OpenJDK and Java never had so rich pipelines in terms of features. There are multiple R&D projects within OpenJDK. Those are long-term, ambitious projects whose goal is to either fundamentally improve or revamp a certain area of the platform, or simply add a completely new capability, a completely new features. A good example, let's take Loom. So Loom's goal is to completely revamp the concurrency model of the Java platform by introducing virtual threads. On the other hand, we have ZGC, and ZGC's goal is to introduce a new capability to the platform, and that is a low latency garbage collector. So we have all those projects going on. There is one that I need to mention, and that is Project Leiden, because that's a new one in 2020. So the goal of Project Leiden is to tackle a long-standing issue that Java is suffering from, and that is the relatively slow startup time and the relatively important static footprint. So Leiden will try to tackle that by bringing the notion of static image to the Java platform and to the JDK. So we have all those projects, and the good news is that given that we have a new release cadence, we have this predictable model where we know that there is a release every 6 months. That basically means that those projects, even though they are running over the course of multiple years, they have a vehicle to deliver gradually and incrementally capabilities to the platform. And we'll see, for example, that Amber has been going on for multiple years. In every release, Amber is bringing new capabilities to the Java platform. And we can also say that, for example, with Loom. We'll see that, well, already today, even though Loom is far from being ready, there are already here and there small bits that are done around the Loom project. The first project that I want to discuss is ZGC, or ZGC if you live in the US. And ZGC is a concurrent, scalable, low-latency garbage collector. So it's a new garbage collector added to the platform. It's concurrent in the sense that all the heavy lifting work is done while the Java thread of your application continue to execute. All GC operations except the thread stack scanning are done while your Java code is running. So that means that the post time will be greatly limited. So typically, we say that post time stays below 10 milliseconds, but what we observe most of the time is that post times are more around 2 milliseconds. It's scalable in the sense that those post time will not increase even if the heaps or the live set size increase. And it's also scalable in the sense that ZGC can handle up to multiple terabyte heaps. We're talking about 16 terabyte heaps. And it can also go down to a few megabyte heap. So it's scaled both ways, if you will. How to use ZGC? It's pretty simple. Since GDK 15, you just have to use that flag. Use ZGC. Then the next thing that you have to do is to tune ZGC. And the good news is that you don't have to do a lot. The only thing that you typically have to do is to set the heap size, the max heap size, using these flags. And obviously, if you want to do more advanced tuning, that's something that you can also do. So ZGC was introduced in GDK 11 back then on Linux only. It was a hotspot experimental features. In 12 and 13, we have improved ZGC. For example, in 13, we have added support for ARM, the ARM platform. The heap size has been increased to 16 terabyte. And in 2020, we have added support for macOS and Windows. The good news is that since GDK 15, so since September 2020, ZGC is not experimental anymore. It's a production feature, so it's something that you can rely on. We're not stopping there. In 16, we plan to introduce this JEP, concurrent thread stack processing, and basically what it means is that the post time will be below 1 milliseconds. So we'll have a low latency sub-milliseconds GC in Java 16. How good is ZGC, you might ask? Don't take my words. This quote is from Monica Beckwith from Microsoft. So she said a few months ago that ZGC shines when it comes to responsiveness. Moving on, Project Valhalla. So the goal of Project Valhalla is to reboot the relationship between the Java virtual machine and the data in memory. We can all agree that Java is very good at optimizing code. I mean that we spend many years on engineering effort to make sure that the JIT compiler, that the hotspot VM always generate highly performant code. So the next obvious step is to look at what can we do on the data front. How can we optimize how data is laid out into memory? So we would like to have a flatter and denser memory layouts. There is a basic issue to achieve that, and that is the Java type system. So don't get me wrong. The Java type system is very powerful, but it misses some flexibility regarding certain aspects. The main issue that we have is that in Java, every object has an identity. That identity has a cost. Well, identity is obviously very important. For example, if you want to have mutable object, well, you need an identity. So again, don't get me wrong. Object needs identity. But there are some use cases where maybe the identity is not needed. Today, there is no way to say that. So Valhalla is looking at introducing inline classes. So basically being able to declare a new object that don't need identity. By doing that, the underlying virtual machine will be able to more optimally lay out those objects into memory. So Valhalla will impact the Java language. Obviously, the Java compiler will be impacted as well. The underlying virtual machine will obviously also be impacted as well. And not only that, some of the core library will also be impacted. So Project Valhalla is really a huge project. So I'm going to switch to hidden class. Why? Because hidden class are developed under the Project Valhalla umbrella. And hidden class have been added in GDK 15. So what are hidden classes? So if we look at language implementation built on top of the Java virtual machine, or even frameworks, all of those, most of the time, rely upon dynamics class generation for flexibility, for performance, and so on and so on. The idea with hidden class is that we will have a new type of classes that cannot be used directly by the bytecode of other classes. So those hidden classes are intended for use by frameworks, for example, that generate those classes at runtime. And that frameworks will use those hidden classes indirectly via reflection. A hidden class has basically three core properties: discoverability, or I should say non-discoverability, lifecycle, Given that we see that frameworks tend to generate a lot of classes at runtime, we need to dispose as quickly as possible those classes so they can be unloaded aggressively. And last but not least, access control. So we can put access control on top of those classes. And this is done using access control nest that was added in JDK 11. Now, as a developer, I don't think that you will directly use hidden classes. But in the future, we can expect frameworks that you use will leverage hidden classes. And obviously, the platform itself will also leverage hidden classes. Moving on, Project Loom. So the goal of Project Loom is, on one hand, very simple, on the other hand, very ambitious. So Project Loom is about making concurrency simple again. How? By introducing a new type of threads, virtual threads. So today, the threads that you are using in Java are native threads. So they are scheduled by the underlying operating system. With Loom, we'll have a new type of thread. So it will be a Java object, and virtual thread will be scheduled not by the underlying operating system, but by the JVM, by Hotspot itself. And those threads are very cheap. As a developer, you don't need to hesitate to use those virtual threads. You can span millions of virtual threads. It doesn't cost anything, basically. The good news is that using those very cheap threads, those lightweight threads, you can develop using a more traditional synchronous blocking approach. So you don't really have to worry that your code is blocking because thread-wise, it doesn't cost anything. So you can write using a more traditional synchronous approach. The good news is that, obviously, under the hood, your application will be able to leverage better the underlying resources, such as network I/O, for example, but also your code will be easier to write, but also easier to observe and easier to debug, because it's way easier to debug and observe synchronous code than it is with asynchronous code application. So we have multiple early access JDK build of Project Loom. And in JDK 15, we have a new JEP that has been added to the platform. That is, re-implement the legacy datagram socket API. And that one is basically a follow-up of something that was done in JDK 13, re-implement the legacy socket API. Even though there are still a lot of work to do, we can see that already today we already have in the platform works that is done in preparation of Project Loom. So again, that's the benefit of the new release cadence. Gradually, those projects can add smaller features into the platform. Project Panama is about enriching the interaction between the Java virtual machine and foreign API. By foreign API, we simply mean native code. Initially, it will be C code, and then that should evolve. So Project Manava will enable to access low-level hardware functionality through normal Java code. Obviously, that's something that you can do today using GNI, but GNI was never meant to be simple. That's something that Panama will address. Panama has two core building blocks: the foreign memory access API, JEP 3.7.0, and the foreign linker API. So the first one is incubating in JDK 15, second incubations. And basically that API allows you to enable efficiently and securely off-heap memory from Java code. So we are talking about accessing securely native memory from Java code. The second API is the foreign linker API. That API will offer statically typed pure Java access to native code. So basically being able to easily and securely invoke native code from Java. So there is a JEP, but that JEP is not yet targeted. I've put two additional APIs which are somehow related to Panama, even though they are not part of Panama. The first one is the non-volatile map byte buffers. It's part of JDK 15 or 14, I can't really remember now. Anyway, it's something that has been added in 2020. So it enables to access non-volatile memory using mapped byte buffer. So that's a very specific corner scenario, so I'm not going to spend time on that. And then we have the vector API, which is basically about using CPU vector extension to achieve superior performance to equivalent scalar computation. So that API will allow you as a developer to express vector computation that will be compiled by the hotspot compiler to optimize vector hardware instruction on CPU that support vector extensions, such as SSC, for example. So that's Panama in a nutshell. The next one is a big one. That's Project Timbre. The goal of Project Timbre is to continuously improve developer productivity through evolution of the Java language. The first feature that we have from Project Timbre was back in Java 10, that was local variable type inference, VAR. And then we had additional feature. In 2020, we get quite a few. We have the switch expression, standard in 14. We have text blocks, standard in 15. Record classes, second preview in 15, pattern matching, for instance of, also second preview in 15, and finally sealed class. So let's have a quick look at that. So the first one is record classes. So record classes provide a compact syntax for declaring classes which are transparent holders for shallowly immutable data. Or more simply said, records are basically data carrier class with less code ceremony. So one thing that records tackle is the verbosity issue that Java has. So let's have a look at a quick demo. Maybe that will be easier. So what I'm going to do, I'm going to create a quick project in IntelliJ. So I'm using GDK 15. I'm going to use this basic template, and I'm going to call that application simply J4K. Okay. Okay, what I'm going to do, I'm going to create a record. So record, let's say that we want to create a record of a person, and then we have to describe the states. So that is the header of the record, and a record have one or multiple components. So let's say that a person record has a last name, it has a first name, and let's say that it has an age. And you see that for each component, obviously, we need to attach a type. And finally, we have to give the body. The body is optional, so that's what I'm doing here. The body is basically empty. You see that my IDE is complaining why preview features in Java IC needs to be explicitly enabled at compile time and at runtime. So you use a special flag, -- enable preview features on Java C and on the Java launcher to basically enable preview features. Here I'm just simply asking IntelliJ to fix that for me. So it's set language level to 15 preview. That's important. And now it compiles nicely. So what we can do now, we can create, let's say, an employee. So an employee is a new person. An employee has a name, do. It has a first name, let's say Joe, and it has an age, let's say 42, right? So let's compile that. So it compiles and everything works. Now let's quickly go here, and I'm going to use Java P to check one of the two classes that I have. So I have the main class, this is my application, and you see that the record person is also a class. So let's decompile that using Java P, and I'm going to use the -p flag so that we can see the private fields. So what do we have here? So first, that class is final. Okay, it extends javalang.record, even though we haven't extended anything here. So that is done at the compiler level. So it's implicit, and a record cannot extend any class. In fact, it cannot even extend that one. This is done implicitly under the hood. So we have some private fields that correspond to the components of the record. So last name, first name, and age. They are private and they are final as well. Finally, we have, let's see, that's the canonical constructor that takes all three components of the record. So last name, first name, and age. And then we have three methods. So three methods have been implemented for us by the Java compiler. That is the toString method, the hash code, and the equals method. Obviously, we have the ability to override those. And last but not least, we have accessor method that enable us to accessor the private fields of the records. So last name, first name, and age. So that means that I can do for something like this, for example. So emp1, let's say last, for example. So I'm using the accessor method to simply access the last name of that employee. So let's run that. And hello, do, with a nice typo. Okay, we can, for example, what we can do, we can implement the canonical constructor. So person, Well, the arguments are pretty simple because it's the one from the record itself. So I'm lazy, I'm going to copy that. So this last equal last, and let's say that, for example, we want to uppercase the last name. This first equal first, and finally this age equal age. Okay. So let's run that again. Hello, and you see that this time the name has been uppercased. This is the canonical constructor, but as you see, it's a bit verbose. The good news is that records are addressing that through a compact canonical constructor that works like this. So what I'm going to do here, I'm going to do the same thing. So I want to uppercase the last name, so last to uppercase, and that's it. It's all it takes to use the canonical compact constructor. So I'm going to comment this one. Okay. So this is a compact constructor. So you see that the other fields like first and age are not initialized. Why? Because at the end of the compact canonical constructor, the canonical constructor is implicitly involved. So if we run that code, oops, sorry, run, well, we have the same result. We can use the compact canonical constructor to do validation or normalization. So let's say that, for example, we want to do, let's see, some validation on the age. So we only want to have adult employee. So if age is below 18, that's not going to work. So throw new let's say illegal argument exception. Sorry, we're only hiring adults at this time. Okay, so let's change our record. So let's say that this time we want to try with Bart Simpson, whose age is, let's say 10. Okay, let's compile that and let's see how that goes. And this is a simple typo. And let's see, well, we have an exception, illegal arguments exception. Sorry, we're only hiring adults at this time. So basically this is how we can use, for example, compact constructor to do validation. Now, the thing that I've done here, I've created a record in a separate classes. So if I have a lot of records, maybe that will be a little bit cumbersome. What I can also do is use a local record. So let's see. So I'm going to take this, and instead of putting it in a classes, I will directly define that constructor, that records within my method. Let's run. And we have this exact same result. Now, if Bart is 20 years old, obviously, hello Simpson, so that's work. So that's the basic idea with records. So let's go back to the slides. So this is a record definition. So a record has at least one component. In this, it has two. A component should have a type, and a record should have can have an optional body. So a record class declares its states. That's basically the header, all the components, and based on that, it can commit to an API that match that states. So for each component, we have a private field, we have a public accessor method, and we also have a canonical constructor. And last but not least, we have three methods, equals, hashcode, and toString that we can override if we need to. So a record is simply a class with some restriction, such as it is implicitly final, it can't be abstract, it cannot declare explicitly instance field, and so on and so on. And those few restrictions are basically emphasized on the fact that a record is defined solely by its state description, by its header. And that state cannot be enhanced later or externally. So a record is a class with some restriction, but also a difference. Serialization and deserialization of records is very secure because it's based on the state component and on the canonical constructor. So at the end of the day, we don't have any funky case. It's basically impossible to create impossible object when using serialization on records. So there are a lot of more to say about records, but I'm just going to say that records should be made final in 16, and there are more to come around the record, such as more pattern matching. So moving on, text blocks. Text blocks are simply multi-line string literals that gives format controls to the developer. So let's quickly switch to a simple demo. So I'm going to use this same example, and what I'm going to do, I will simply create a new file that says, let's say, yes, HTML. So that's a simple HTML snippet that I'm going to try to use within my application here. Well, most of the time this is very cumbersome. Now with text blocks, we can do this. So we create a text block using this new triple quotes delimiter, and that's it. We have a text blocks. So snippet, and let's run that. And you'll see that basically the format is preserved. So the format is aligned on the closing triple quotes delimiter. So that's very convenient because a lot of time we have to embed structured text within Java code, such as Java code itself, for example, or JSON or SQL or XML. What we can also do, for example, we can say that, let's say, we want to change the title. We have this new formatted method that we can use, and let's say this is the new title. Okay. And you see we can use to do some simple insertion replacement within the text blocks. Now, at the end of the day, this is simply a multi-line string literals. So that basically means that we have access to the string API. So what we could also do, for example, replace. Oops, sorry, replace. And what we want to replace, let's say EN, we want to replace that and set that to French. You see here that we have English. And if we run that, this time we should have French. So let's go back to the slide. So if you want to learn more about text block, check out the programmer guide. Let's switch to switch expression. So what you see here on the left side is a switch statement that you have probably used for many years. There's multiple issues with that one. The first one is that if you look at Monday, Friday, and Sunday, there's no break. So that means that as soon as we hit one of that case, it will fall through until it hit a break. And you see that the break, we have one for Tuesday. So if we have, let's say, Monday, for example, number of car will be 6, and then it will be 7 at the end. This code is a bit verbose. So you see that for Monday, Friday, and Sunday, we have 3 cases, even though we just basically want to do the same thing. Not only that, if you look at the bottom, we have a default branch, which honestly will never be reached. Why? Because we are doing a switch on an enumeration of 7 days. And if you look at the code, the 7 days are there. So a switch expression is basically solving all those issues. So this is the same code using switch expression. One key difference between a switch statement on the left and switch expression on the right, the switch expression returns value. And you see we have this notation, dash, bigger sign 6, so arrow. So basically that means that for Monday, Friday, and Sunday, we want to return 6. We also have the ability to add instead some curly braces if we need to do some more complex computation. In that case, we're going to use yield to return the value that has been computed. You can also notice that we can use multiple labels. So case Monday, Friday, and Sunday, that's way clearer than what we have on the left side. Not only that, we don't have a default branch. And if we would have one, the compiler would complain because the compiler knows that we are doing a switch on an enum. So it knows all the value of the enums. So it knows that we are doing an exhaustive test. So it will complain and saying that the default branch will never be reached. Moving on, let's quickly discuss about class hierarchy. So class hierarchy enables code reuse via inheritance. You have a superclass that has some methods, and all the subclasses of that superclass can reuse that code. The problem is that sometimes class hierarchy is also used to model the different possibility of a business domain. Just imagine, we have a graphical library, so it needs to deal with shapes. So we have a shapes And we can have sub-shapes like a square, an hexagon, a circle, and so on. All those sub-shapes, square, hexagon, circle, triangle, extend shape. Now, there is no way to say that, okay, we only want those 4 shapes to extend the superclass. So it would be good to have more flexibility that would enable us to write such a code, because code reuse is not necessarily always the end goal of a class hierarchy. So what we need is a class hierarchy that would be closed, and it won't be open for extension by any class. Basically, code reuse would still be possible, but within a well-defined and closed class hierarchy. And that is what Silk class is bringing to the platform. So Silk class allows a class or interface to control which code is responsible for implementing it. This is an example. So this is the super shape. So you see that we have this new sealed keyword here to say that, okay, this class is sealed. So what it means is that only the class that I will explicitly authorize to extend a shape will be able to do so. So we permit circle, rectangle, and square to extend shape. But what if, for example, I try to extend rectangle? All those classes which are part of a sealed class needs to be either sealed as well, non-sealed, or final. So if the class are in the same module or in the same package, you don't need to use the fully qualified name of the classes. And a little trick is that if you are using nested class, so if you have multiple classes within one single class file, the subclasses don't need to be explicitly permitted, because if they are in the same class as the super class, automatically the compiler will infer that they are permitted to extend the super class by default. Pattern matching for instance of. I guess you have all written that code. So if obj instance of string, we create a new string s whose type is string, and we cast obj to that object. It's a bit verbose because we have, for example, the type string 3 times. These new features basically simplify that by adding a binding variable in the test pattern. So if obj instance of string variable s, that binding variable will be automatically created, and we can use it in that scope. So we discussed some of those OpenJDK projects that either completely revamped one aspect of the platform, for example, Loom for Java concurrency, or add a completely new feature to the platform, the GC, for example. Despite being projects that run over multiple years, we also saw that the predictable release cadence enabled those projects to gradually and incrementally add new features to the platform. A perfect illustration of that is Project Amber, who is, since Java 10, adding new Java language features to the platform. Finally, we also quickly looked at some of the new features that Project Amber gave us in 2020, such as record, text blocks, and so on. Now, all new JDK features are not necessarily emerging from those projects. In addition to those projects, there are many other areas that we keep investing in. For example, G1. It's not because we now have the GC as a production GC that we're stopping to invest in G1. In fact, since JDK 8, we made more than 700 enhancements to G1, and together all those enhancements greatly improve G1. For example, this chart shows the additional native memory needed to handle a 16 GB heap with G1. And as you can see, in JDK 8, it was around 4 GB. It then went down to around 2.7 GB in 11, to finally be around 1.7 GB in 14. That's a huge improvement. Another welcome improvement is the following one: helpful null pointer exception. We all had that kind of exception. So we have a null pointer exception so this is the class that throws that exception, and this is the line. So we just have to look at that line to understand what is going on. Well, sometimes we have code like this. And in that case, it's a bit hard to really understand where the null pointer is thrown. So in JDK 14, we have this new flag, show code details in exception messages, that give us more information to more easily pinpoint where the null pointer is thrown. Now, that was added in 14, but in 15, the behavior has changed. That flag is enabled by default. Another area that we keep investing, for example, is GFR. In itself, GFR is not new. It has been open source around the time frame of GTK 11. So it is like a flight recorder in a plane. GFR records events that are emitted by your application, but also by the hotspot virtual machine. And then later you can use all those events, correlate them together to understand what is going on. So you can easily pinpoint issue using GFR. And it's also low overhead, so you can use it into production. And with each release, we keep improving GFR. For example, we are adding new event type. Another area that we have investing in around GFR is in GTK 14. We have event streaming. So until now, you would use GFR recording. So basically, you start a recording, you let your application run for a while, then you stop the recording, the GFR recording, you dump the content to a disk that you can then analyze. This approach works well for application profiling, but not for monitoring purposes. So that's something that is now possible with GFR. So it's possible to expose GFR data for continuous monitoring, continuous consumption. And those are just examples. So there are many more areas that are not tied to those large projects that we mentioned earlier that we invest on. So now it's time to wrap up. We discussed the GST. We also discussed Project Timbre and features such as Record, for example. We also touched on Project Loom, Project Panama, and so on. Altogether, those projects will shape the future of Java. We also saw that today, using the new release cadence, they are already adding new capabilities to the platform. Java in 2020, we had two releases, 14 and 15, so that's 30 JEPs in total. The JEPs only gives a partial view of a given release. So it's important to look at a release as a whole. So for example, in GTK 15, we have added support for C group v2, which is important when it comes to running containers in a rootless container environment, such as Podman, for example. We have also added support for Unicode 13, and so on and so on. And clearly, those features are not tied to any JEPs. Now, obviously, a new Java release also comes with its set of bug fixes and improvements. But more important than that are the security fixes that are brought with each Java release. To leverage those security fixes, you need to make sure to use the latest release of OpenJDK. So the call to action today, download please Java 15. It has been released a few weeks ago, so you should start to use Java 15. So OpenJDK 15 is as of today the supported version. It's free, and from a security standpoint, it is supported. Now, we understand that not everybody is able to switch to the latest OpenJDK release. So that is why Oracle has also a commercial support offering for the Oracle JDK. Now, whenever you look at buying commercial support from an organization, it's good to look at the ability that that organization has to support you. So this slide is showing the fixes that have been done in GTK 15 per organization, and it's always nice to keep that in mind. So finally, I would like to conclude by mentioning Inside.java. So that's a new website that discusses Java and OpenJDK, and just that. We have launched that website a few months ago in 2020, and recently we have added a new podcast, the Inside Java podcast. So please check it out, inside.java/podcast. With that, I'd like to thank you for your time, and I wish you a pleasant J4K. Thank you. Bye-bye.